So let's start. My name is Alon Rosenthal. I'm SecuPi CEO, co-founder. I invented dynamic masking in the past. Been doing data privacy for over 15 years, and I'm happy to share our journey into the identification of sensitive data when onboarding AI and cloud analytics. We start by the definition of everything, right? Security, privacy, governance. A good boilerplate can be seen in the zero trust. The zero trust is a basic notion of how to protect data. And when you look at the zero trust evolution, the zero trust is a basic notion to protect data, and especially in AI, right, taking that one step forward. So as a reference, it's always nice to look back and see how zero trust looks at cloud platforms, and hence the old way to protect data, which was very network-centric, now with the adoption of new cloud platforms, is changing into data-centric. And the reason I'm mentioning that, because AI, cloud analytics, all the things that we're going to talk about are primarily around data. So it's always nice to see that also the industry, the cybersecurity industry, is also putting and shifting its viewpoint into data centricity, where the notable features, tagging of data, dynamic masking of data, attribute-based access control, data loss prevention, encryption of fields and records, these are now becoming the main cyber focus, and especially as we are now talking about AI. So this is a nice way that we are coming into fruition from a cybersecurity posture. But now double-clicking on where the focus of the meeting, which is how we look at analytics and AI in specific, regarding the protection, the governance, the privacy, the security around it. And the way that we look at it is first looking at the journey that analytics and AI are moving from testing, demoing, doing some modeling of sensitive data, and until the model is released into actual providing benefit, sharing the model, monetizing the model, and sharing for enrichment. And through this journey of moving from data into monetization of the data, we can divide it into three main pillars, where we have the different stakeholders that are using the data, the analysts, the data scientists, but also privileged users, DevOps, cloud admins, who have also access to our environment, business users. It can be a dashboard provided to the business users to see the analytics results. Maybe it can be Power BI or Tableau, but it can also be a custom portal that gives business users access to the data. But also we see more and more offshore and third party have access to the data. And we need to provide a solution that will identify sensitive data, control access to data to all of those different stakeholders. So definitely extend your viewpoint from just let's protect the analysts and the data scientists that have access to maybe Databricks or Snowflake, but also look over and beyond around other type of persona that have access to the data, such as the privileged users, offshore, outsourced, consultants, etc., etc. There, the theme of segregation of duties is important, because who protects the Snowflake account admin, right? Definitely including that into scope is important. And then from the who, where, right? And the where we are talking about, of course, our enterprise trusted environment, right? From our on-prem Teradata, as the data is lifting to, whether this is EMR or Databricks, Snowflake, Redshift, BigQuery, and others. These are perceived as our own platform, and hence clear text data, creating speed of analytics, utility of the data is available. But then we have other environments, or even other, in the case, for example, of Spark, we allow Spark to run on other type of buckets where sensitive data is proliferated, And there we might need to apply some partial identification as we are providing compute on buckets that include even credit cards or sensitive data, right? We want to start to identify sensitive data elements within those bucket, AVO, CSV files, and others. And then last and not least, the untrusted environments, right? Whether this is a query that I'm shooting from my Snowflake or Databricks into ChatGPT, right? The interfaces from our protected environment to the untrusted environment outside of our domain, right? There definitely the identification is needed. If anything I'm sharing to the outside world, I need to ensure that it is identified completely. To address all of the three different environments and also looking to the different users, we need to deploy different ways of protection. The identification includes protection of data at rest, but what about protection of data in use? Through the lens of dynamic masking, filtering access of certain type of personas to the data, as well as applying form preserving encryption, types of encryption to certain type of data elements. So in order to protect both the different personas as well as a different type of private sensitive data, credit card definitely needs to be encrypted, but maybe addresses or zip codes, they can be filtered to a certain number of digits or numbers, right? And this can be protected both at rest when we are lifting from our on-premise operational stores data to Snowflake or Databricks, and it can be also done in use as those environments are used by different personas. And that's why a complete platform with different feature sets is required to address the different requirements that we see here, from the data identification at rest, protection of data in use, but also monitoring and tagging access to sensitive data, right? The theme that was also mentioned by Zero Trust. So as we want to embrace the Zero Trust notion also into our cloud analytics and AI, right, makes sense that we need all of those functions and features together in a single platform. And that's really why we built SecuPi in all of those capabilities blended together, so I can really pull in the relevant capability to the relevant environment, use case, the identification level in the environment, and the persona that is accessing this information. Double clicking on the type of the identification, right? It all starts with a simple form of preserved encryption tokenization. But here we can definitely dive into maybe applying form preserved encryption just to parts of the column. Let's take, for example, an email. So maybe we can encrypt the domain or just encrypt the name of the complete email. Or if you look at the social security number, we might want to encrypt just the first 6 digits, remaining the other digits in clear. But other types of encryption are available, AES encryption, AED encryption. But form preserved encryption is not good enough because form preserved encryption is not type preserving encryption. Something else needs to be added. Because form preserved encryption, if you take, for example, an integer and encrypt it, it might be changed into a long, and then the column type needs to be changed. And when we want to apply the identification across structured, semi-structured, we need to keep the type of the column so we can create a Snowflake clone now with the same column type in our tables that we are cloning from a protected environment to a less protected environment. So to do that on a type preserving, that's why we also provide the ability to increase the encryption into a more restricted type of encryption, where we can take, for example, a byte and encrypt it into a byte. Right? When we take an integer and are able to enter an encrypted format, will also be an integer. And also dates. Dates are very complicated when you do encryption because dates have thousands of different formats of a date. But when you take a date and you just do form preserved encryption, you get into strange dates, which are the same format, but are still not valid date type. For example, encrypting form preserved encryption of the 23rd of February can be 38th of the 13th, 0066, right? It's the same format, but it's not a date type. And that's why also adding to our to our Swiss knife, the ability to do type-safe encryption is important. So a date encrypted should fall within a certain time frame, right? Maybe we want to encrypt the date to plus minus 20 years before and after. So giving it a range, the date type, is important as well. Doing that type-safe encryption allows us to do and to use the same encrypted value across operational and analytical stores. So we can do the same encryption, encrypting the same data into the same value across different silos, both in our cloud analytics or in Snowflake, Redshift, and other platforms. Other types of identification functions that come to mind include also blurring. Blurring is a way to keep values that are a very small range of values, such as blood type or gender, and allowing to encrypt in such a way that it persists against statistical hacking. Right? Let's take, for example, gender. Right? In any large data set, there will be more women than men. Right? So by just changing that to a different value won't help. So that's why we also provide a blurring effect for low entropy data, where we can take, for example, blood type and encrypt it to multiple values. The decryption of all of those different values will go back and persist into blood type A+, but at least it will be resistant against statistical hacking. Other types of identification functions that come to mind, of course, are bucketing, where we can bucket or round birth date into the first of each month. The dynamic masking, replacing, zeroing, nullifying, but also obfuscation, changing a name into a name. The obfuscation, of course, is very valuable when you're creating a data set for training our model. So we can simply blur or obfuscate the names. So we are able to keep like a nice set of names, but they are blurred. They are, of course, completely identified. So these are also different type of identification functions that are part of identification platform. The next question is, of course, how to do that, right? How are we able to apply the identification at scale at different cloud environments? Where two main places needs to be protected. The first piece is the ingestion. As data moves from operational stores to analytical stores, we need to be able to enforce the identification across those different stores. And as those, let's take Informatic, for example, or Kafka, or Azure Data Factory, or Glue, they are consistently being used, and a control of those processes is required, because otherwise you can simply lose your ability to control the sensitive data that is lifted to the cloud analytic platform, to the AI platforms. So for that, an agent is required, an agent that we can simply put on different ingestion technologies such as Kafka or Talent or Informatica, whatever. And those agents are able to instrument the flow themselves. Think of it like a driver wrapper, that every time that this ingestion tool is accessing your mainframe or your Oracle database or your SQL server and is touching and lifting data from your customer table in Oracle, every time it is pulling data from the customer's table, it will be de-identified, masking, encryption similarly. So every process, ingestion process that you are taking, that you are building across those different flows, inflows, will be consistently encrypted. And this is the best way to do it, of course, is just to put this, think of it like wrapping your driver. So every call to any type of data source, on-prem or in your cloud, will be consistently masked. You don't need to take care of calling an encryption function every time a new person is creating a new ingestion flow. So tying up and closing and hardening the ingestion flows are very, very important. This is something that we do with those agents that we put on the different ingestion, whether this is a very common use cases on Glue and on Spark, but also on Azure Data Factory and a lot of Kafka, where we can put an agent on the Kafka producer. Then we need to look at the other side, at the consuming applications, whether this is Tableau or Click or Power BI or even a Jupyter Notebook. And we want to apply the re-identification not on the cloud platform itself, but try to put it or shifting the re-identification left as much as possible. Why? Because if you take, for example, a Tableau or Click, in many cases, the requests on the result of our AI model will be sent through a service account, right? I'm a Tableau user. The Tableau, through the Tableau server, is connecting with a service account to the data store. So the data store receives a request, an anonymous request from some kind of an application. And that's why we try to shift left in the sense that we want to apply the re-identification as close as possible to the user. So for example, we are able to do the re-identification not on Snowflake using a Snowflake external function, which by the way, also another reason for not doing that using a Snowflake external function is to ensure full segregation of duties to the Snowflake account admin that can also invoke this external function and decrypt our model results. That's why we are trying always to shift as much as possible to the end user, to the application used to consume the results of our AI in order to be able to control the data and to protect it as much as possible. This is also a common use case that we see with organizations that have a global presence, because what happens is in those cases is that in the today model where data is being encrypted on the platform themselves, maybe using a Snowflake external function or Redshift or BigQuery, the BigQuery DLP, right? The data is returned decrypted back to those platforms. Right? This is usually hidden, but this is physics. People understand that when I'm using either the Snowflake native encryption or I'm using even a third-party encryption, but I'm invoking the decryption functionality through an external function, the data will be eventually decrypted back to Snowflake as it is being returned back to the end user, to the analyst. And this is an issue with sovereignty laws. It is also an issue with segregation of duties. So for the few columns that we are that we need really tight controls on, take for example credit card, take for example our data set with Chinese employee data for our HR schema, which must not be decrypted outside of China, taking for example China, but the same is in Singapore and Malaysia and other countries, but also Shrimp too for European HR schema. We see the same. We need also to offer an ability to re-identify those outside of the cloud data platform. And we do it with this, again, this shift left mentality of taking and applying the re-identification to the user, whether this is done through an agent that I'm putting on the Tableau or using a transparent gateway outside of the Snowflake, outside of BigQuery or Redshift or Databricks and other cloud platforms like that. So that's another thing that you might need to take into consideration for highly regulated data sets that you have. The entire model then looks as the following, where we have a centralized management server. And the purpose of the centralized management server is to pull those conditions, those policies and attributes that we need to take a decision upon, right? The user role, the user location, consent of the customer, whether the customer has to be forgotten and he has not given our consent for any AI processing. We might want to either delete his information through the ingestion or filter him out as we are consuming the results of the model. In order to identify whether this customer information has gone through consent or is within the retention period or even requires to be completely deleted, we need to get attributes, we need to get the context, and we do that through REST API and existing integration, for example, SAML assertion from different IAM environments, SailPoint, Okta, Ping, but also Salesforce, etc. We also want to get user context, the data context. And we have our own data classification. We can use the Purview, we can use Colibri, Deletion, Informatica, all other data catalogs out there in order to enrich our policies, not only with the who, but also with the what. And once we have those attributes and the policies defined, then we can push it down to the enforcers. And we talked about few enforcers until now. We talked about agent that we put on the ingestion. We talked about agents or gateways that we put uh, before the consuming application. So the enforcers are self-contained. They need to be holding those policies and relevant attributes. And the reason I need to poll that is in order to scale. Because if I need to ask our centralized management server, for example, decrypt this payload, or should this user have access to this information, right? This will create a huge choke point to our cloud analytics platform. We want to be able to distribute the enforcement points as much as possible. And for that, the model that we have provided is to build 4 different enforcement technologies that are there for scale. And the reason we provide 4 options because we have highly regulated customers, Fortune 500, and they need flexibility, they need options. So in some cases, we'll use the agent. In some cases, we'll use transparent gateways. For example, maybe transparent gateway in front of Redshift or Snowflake or Databricks. We might resort to maybe provide an SDK for decryption, encryption, local decryption using a simple SDK, right? Or simply create native those policies. So we will resort to one of those 4 options based on the technology stack and the need. And those 4 technology enforcers are able to apply across basically every type of compute platform that you choose, where this is across cloud, but also we have customers who use SecuPi both for Teradata and Snowflake encryption. They want to have persistent encryption both for Teradata, Exadata, and Snowflake because some data was not still allowed to live to Snowflake and is still persistent on-prem. While they're moving more and more data to Snowflake, still a lot of processing is done on on-prem analytics environments, and hence we need to provide the same identification function on both on-prem and cloud environments. So that's why we are providing also enforcement technologies for even the legacy technologies as well. In order to talk about the different type of identification, we also talk about what we call attribute-based access control, which comes to fruition through different type of controls, whether we want to control the entire access to the data set or to the database or to the schema, right? An object level access, whether we allow certain type of users to create or delete or drop objects from the data set. This is primarily to control what our privileged users are allowed to do. But then thereafter, we want also to control access to data sets based on role level. For example, US customers are allowed to be presented, but not Swiss customers or not, as I mentioned, employee data from China. So we want also to identify on role level, but also column level, completely de-identifying PII for certain personas. Also, this is a very common use case when we do, for example, offshore and outsource that have access to our cloud analytics environment. We might simply want to create this cross-grain policy, everything classified as PII or everything classified as C4 type of data needs to be de-identified for those types of users, roles, logging in from those systems and applications, but also doing that even on the cell level. So all of these are different ways to protect data through different type of de-identification techniques, whether they are the identification techniques that we talked about before, the encryption, tokenization, types of encryption, that can be done at rest as data is moved from one data set to another, and maybe through a Spark job that is taking a sensitive data set and cloning it to other data sets, or through the ingestion flows from putting agents on the Kafka, the Informatica, the data stage, CDC, and other type of technologies, but also the protection of data in use, identification, the identification of data in use that is being consumed by different stakeholders. So all of that needs to come to fruition when we talk about a complete protection of our cloud analytics and AI results. So this is a summary of how we perceive this challenge through the different lens that we see at large customers. And now I will let Jonathan to do a quick demonstration of how it looks like when we put such an enforcer on ingestion as well as on a consuming application. Jonathan, if you can take the presenter.
I suppose the first question is, what can you see?
Okay, we can see you. Thank you.
Perfect. So I'm just trying to move that over to the other screen. So this is a very simple setup. I'll talk through it in a moment, but I have a set of data here that's in clear text. So I'll just run it so you get to see it. But as we're running it, so basically, I've got an input from an S3 bucket, an output to an S3 bucket if I need to write things out. I've read a set of data into a table, into a data frame called customer test. So I've looked at the amount of data that's in there, and I've got 100,000 lines. This is the schema, and then you get to see the data set appear. So if we look here, ID, job, email, name, all of this is in clear text. So great, I hear you say, what's the use of this? What I'm going to show you is the idea of dynamic masking on the fly. So we can then, once we have it encrypted or masked, we can then utilize it in different ways, as Alan's already spoken about. So the clear text data starts. I'm just going to change it quickly into masked and then rerun.
This is the SecuPi management server, by the way, right? That is, yeah, that is where we are maintaining the identification in a consistent way across all of our ingestion, whether this is to analytic environment, but also operational environments. That's where the policies are being defined and then are beginning to be pushed down to the different enforcer. In this case, an enforcer sitting on a Jupyter, but again, other enforcers sitting on Informatica or Talent or Kafka, etc.
Coming back to what Alan talked about, we can do this in multiple ways. I've just chosen for this simple example to de-identify by masking the email and the name column. We could have done it for any number of these. It just gives you an idea of what's happening, and masking it to X makes life a lot easier for people to understand. But if you're actually going to use it in real time, you want to mask it to encrypted or de-identify it to encrypted. So if I change that, what we'll do is run this again. And now you get to see encrypted data. And this allows you then to offload it to CSV if you want to, or we can offload it to Parquet, depending upon how you want to do it. So remember, this is all being done on the fly as we speak. So if I do Parquet, we'll download this and then have a look at it. I've got a simple Parquet viewer down here. The nice thing is, as you can see here, the data sets that we create, as you offload them, if I go and find the latest one, let's refresh that, make sure it is the latest one.
a common theme that relates to what Jonathan is now presenting is the proliferation of sensitive data by data scientists who simply would take like sensitive data which is protected, but then just create more and more through Spark or Jupyter and other means, and just start to clone your sensitive data more and more, right? Across different packet files, etc. So this utility where we are sitting both on the Spark level for EMR or Databricks on the worker node, as well as on the Jupyter, we are able to control the proliferation of sensitive data through our different data sets and prevent the sensitive data sprawl and out of control. And with the ability to apply the types of encryption, it keeps the persistency of those data elements.
I think the important thing to also highlight here is the fact that we have not imposed any code onto Spark. We have written it, and we have a structure where we call a certain bootstrap that allows us to create on the fly, and then the configuration allows us to implement our enforcers. So this allows you to see how or where we're driving things from, but it's all built on the fly as you start the cluster. Yeah. It's we don't have to code it beforehand.
Yeah, we call this concept defense in depth, which means that whatever even the EMR account admin or the Spark account admin, right, can do, it is continuously controlled and audited, monitored, and protected. Right? So that's by putting those agents in really in the boot of every cluster that is spawned, we can control the sensitivity of the data and ensure that it's governed at all times.
So, as Alan said, it's a case of it depends on where your data resides. I've in previous incarnations did a lot with network-based microsegmentation, and I'd always start the process by saying, where does the data start and stop? And it starts and stops on the databases. And it doesn't matter if that database is on-premise or in the cloud, that's where the data resides. And at the point now, if we're starting to look at a data-centric security model, and everybody's moving in that direction, it's a case where you need to start with your data encrypted and unencrypt as close as possible to the user or the consumer. And so that idea moving forward is a case of, I've just got a simple example of an ETL solution here, which is NiFi, but it's another Apache product, so it could be Kafka, it could be whatever, but it's just giving you an idea. So I have a process which is a get file, I have a SecuPi processor, and then I'm going to put the file, I'm going to just put it to somewhere else. I could put this to a database, I could put this wherever you want it to go. Sorry. So I'm putting the file here locally to my data, to my hard disk, just to make the process easier. So if I take a source, which is empty, I'm going to take a file, a small file, just because it's a demo, but you can start seeing here that we have, again, marketing, an email address, name, credit card, social security number, and it's the idea of taking data prior to you moving it anywhere, you need to encrypt it. So it's a case you take a copy of this, and I've named this easily for me to remember during a POC, but I've called my ingestion point source. And I'm sure the output will be to destination, but you can see it running through a process here, which it gets the file from a source, it encrypts it, adds an attribute, and then puts the file out. I could write it to a database, but I've chosen not to in this case. So if we now go to destination, you get to see that it's got the date stamp on it, and the elements now are encrypted. But this time, rather than seeing format preserving encryption, as you saw previously, this is just a standard AES 256-bit type encryption for the job, and I chose job just out of any column you can encrypt or as you need to, but it's the idea of different methods, as Alan's spoken about. Here we have the idea of format preserving encryption. So we've kept the .com clear at the end. We've got kept the @ in the middle, so your downstream systems can appreciate and understand that it's an email address, but they're not going to be able, if anyone steals this, they're not going to be able to do anything with it. And then the same for the name. So the name again is format preserving. So we know it's 6 characters, space, 5 characters. We've also, interestingly, encrypted the credit card number, but we've kept the structure following the LUN card algorithm to make sure it's a valid number. It's just not a valid number relating to the information that's given here. So it's allowing us to do a lot of things. But the idea here is, as you start looking at your data lifecycle, you will want to encrypt close to the source or the production point. And then that gives you the freedom to move that data where you want to. You can keep it on premise, or you could put it into the cloud, or you could do both. And then when you come to consume it, you decrypt it. And then you use it. And potentially, I mean, myself and Alan, changing the subject slightly, are talking to a number of customers that are using this level of anonymization to take their data and use it in their pre-prod systems, which allows them to save money having to build data sets. They can use relevant data sets that are anonymized. But that's slightly off the tack. Sorry, I apologize.
So to summarize what we've shown you here, right? It's the ability to deploy with no-code changes a comprehensive data identification platform for all ingestion flows into the cloud analytics and AI, as well as on the consuming side, whether this is the persona of the analyst, the data scientist, or the privileged user, and providing 3 layers of protection, both the monitoring and the tagging of sensitive data, controlling actions, the fine-grained access control based on different attributes, whether this is location or purpose or deletion attribute of a customer, as well as completely identifying the data through types of encryption, form preserving encryption, tokenization, different type of bucketing and rounding and obfuscation, as well as applying right of erasure, both physical deletion or logical deletion. As users are consuming the data set, we can either physically delete those customers from the data set or logically delete it as they are being consumed. All of this comes into realization when needs to protection of AI and cloud analytics. So thank you very much for spending the time with me and with Jonathan, and I hope to meet you each one of you soon. Thank you very much.
Thank you.